Good evening. I'm Tim Marshall, Chair of the Royal Television Society Thames Valley Technology Centre. Welcome to this, the first of our 3 sessions this week, when we'll be looking at how cloud infrastructure is influencing the broadcast landscape. We'll also be looking at some of the opportunities and the challenges that such developments raise. If you've got any questions, then please put them in the Q&A so that we can address them at the end of the session. So, in this, our first session, we'll go to the start of the workflow and explore how content gets uploaded to the cloud in the first place. David.
Hello everybody, my name's David Walker. I am a AWS Specialist Solutions Architect, focusing on the media services and elemental product line. Today I'll be talking about uploading live content into the cloud. I'll just run through a quick agenda for this call, which will be an introduction, commonly used technology, contribution to the cloud playout and production workflows. So there'll be some examples, I'll talk through some of the technologies and how everything works. But first off, I'll just do a quick introduction about myself. I've been working with AWS now on and off for nearly 6 years. I predominantly look after the Scandinavian and Baltic regions. So I work with everybody from tier 1 broadcasters right down to startups and people that don't normally deal with video. Very interesting role, love the role, and yet keeps me very, very busy. So the main point we're here to talk today about is we're talking about uploading video content into the cloud and what the common use cases are, what the common technologies are, and what people tend to be using when they're doing this. So I'll start with some of the commonly used technologies that we see on a day-to-day basis. A lot of these will be familiar to you. I'll start with the first one, so Rtmp, real-time messaging protocol. Also predominantly used now is Rtmp-S, which uses SSL. It's the go-to prosumer and still used by a lot of people for producing contribution feeds into the cloud or into third-party platforms as a service or solutions, software as a service. It's kind of the go-to for things like Facebook, YouTube, Twitch, a lot of the other streaming platforms. It's quite an old technology now, but it's still going, and a lot of people still do it. It does give you some good latency. Its compatibility, almost everything does Rtmp out, and almost most things you can configure to receive Rtmp or Rtmp-S at some point. One of Rtmps I don't think going anywhere for a while because it's, as I said, so widely used. The one thing with Rtmp is it lacks support for anything other than H.264 or AVC. There are some custom implementations out there that will allow you to do HEVC, but generally out of the box Rtmp and Rtmp-S solutions only support HEVC, only support H.264, and also it's not officially being updated anymore. Next one would be RTP with Feck, widely used in the video networks within TV stations, within broadcast networks, predominantly used in the multicast format to move SPTSs, so single program transport streams, or MPTS, multi-program transport streams around. Can also be used with unicast, which you do need to do when you're doing anything with the cloud. So the cloud multicast and the cloud don't work together. There are ways of doing that via various methods, but generally we'll just say at the moment multicast in the cloud, unless you're prepared to do quite a custom implementation, it's not always the easiest thing to set up. FEC is great. It's forward error correction. It's a technique used for error control in data transmission. It adds redundant data to it, which means that if anything's lost, it tends to be in there. You can tend to get it in the additional redundant data that's sent, and it uses the redundant data to kind of correct any issues in transmission. Feck is good, but it obviously adds, well, it doesn't obviously, it adds a little bit of latency, and it can add overhead to the stream. Generally, depending on how many rows and columns you use with Feck, it can increase the overhead of the video stream by quite a lot. We do see a lot of people using RTP with Feck to send some streams into the cloud, or particularly over things like private connections, or when you're talking in the terms of AWS, we have a concept of what we call direct connect, which is applicable for all of these protocols listed on the presentation. But direct connect is a fiber connection from your on-premise solution, your on-premise facility, or trackside or stadium. It's a fiber connection that eliminates the the first mile internet connectivity issues we commonly see, and it also has it comes in speeds like up to 100 gigabits per second depending on your location. So using direct connect means that you are having a managed connection between site A and the AWS cloud. So yeah, that we can use that on all of these protocols, but some people do use it with Rtp with Feck as well. Zigzi Protocol uses a combination of forward error correction and automatic repeat requests. So it's an error control, or ARQ. It's an error control and packet recovery method, and it's where the receiver sends an alert to the sender that if a packet's missing, so the sender can resend that packet. Well suited to using over public internet because it requires less bandwidth than a lot of the other error correction methods. But it also adds a tiny bit of latency. But we do see a lot of people using Zigzi. Things like the Media Connect service, which I will talk about in a little bit, but that is an AWS service for video transportation using the AWS backbone. So it supports a number of the protocols mentioned on the screen, and we'll cover that in a little bit further on. SRT, again, it's a great protocol. It's open source. It's widely regarded to be kind of the successor or replacement for Rtmp in the future. Great advantages, codec agnostic, really good latency on it, and you can also have caller or listener mode, so you can use that to traverse firewalls, or you can use that to you can have the device call into it, or you can have the receiver call out to the sender basically. So there's great ways of using SRT along those lines. RIST. So RIST is Reliable Internet Stream Transport. It's another open source, open specification transport protocol. It's designed for reliable transmission of audio and video. There's two ways of using RIST mainly. There's the RIST Simple Profile, which is broadcast live content can be streamed into a public cloud environment using standard lease lines, and it's got recoverable. And we've got the RIST main profile, which adds encryption as well, but it also allows you to stream to multiple content or multiple RIST receivers at the same time. NDI is very popular, so network device interface. It's a standard for video transport across gigabit LAN, very similar to 2110. Precise moment, AWS doesn't have a lot of support in the media services for NDI. We have a lot of customers transmitting NDI via direct connect into their VPC, so their virtual private cloud, which is like your miniature little corner of AWS. So that's, you can control the security, you control the access, you can set up EC2 instances for compute, you can have lots of different AWS services running in there, and using a direct connect you could drop your NDI directly into that for utilization on various software running on EC2 instances as an example. Another one I'm seeing personally a lot of uptake on recently is SMPTE ST211022. So that is a constant bitrate, lightly compressed video stream over IP. It is generally using, or almost always using, JPEG XS, and with a lot of the processes and a lot of the way we see customers using this, because of the bit rates, they can be quite high depending on how you set your compression ratio with JPEG XS. The bit rates can be fairly high, so we recommend using something like Direct Connect to bring that into the cloud. So in the scenario here, you would use an encoder to encode your SDI input, create a JPEG XS output encapsulated in 211022, and then you would use Direct Connect to send that into AWS. You can use Media Connect as a method of transporting that video content around, and we would also, which I'll cover a little bit later, but what we also do is we would use CDI. So Media Connect supports decode of JPEG XS or 211022 streams into CDI. So CDI is a open source protocol that AWS have created called Cloud Digital Interface, and it's for moving video around the AWS cloud uncompressed. So you can take your JPEG XS or 211022 stream into AWS via Media Connect. Media Connect can decode that JPEG XS stream into CDI, and then you can output that into your virtual private cloud or VPC to utilize in EC2 instances. So these are some of the commonly used technologies I see on a day-to-day basis. A lot of them have pros and cons. I'm not really going to go massively into the pros and cons of these, but these tend to be the main ones I see, and I see a lot of, depending on the workflow, I see a lot of different use cases, but I see a lot of Zigzi, RIST, and SRT coming through at the moment, as well as for particular social media streams that go into multiple locations. I do also see a lot of Rtmp coming in as well. So what are customers trying to achieve with this? What are people trying to achieve? And one of the main things we kind of see with customers is they're trying to improve their latency. They're trying to get better latency, better quality. And one thing with the general, you'll see big pushes over the next few years into low latency HLS and what you do when you get the content into the cloud. I personally really like this slide because it shows you what the general latencies are on the technology, what their use cases are, and we generally see sort of 6 seconds is the typical broadcast latency when you get into the direct to home cable, and then you get sort of into the lower latencies when you're talking about voice, live auctions, gambling, betting, and there's often a trade-off at times between, not always a trade-off at times, but latency and quality. So if you want some of the technologies we have, they're incredibly give you incredible high quality and great redundancy and scalability, but then you can have a trade-off sometimes with so you can have latency but great, you can have an additional bit of latency but have great quality. I've just run through kind of a few examples of cloud contribution and what you can do with the content in the cloud. So one of the main ones we kind of see, this is an example using the AWS media services. Other media technologies are available and fairly easy to use as well within AWS, but in this example what we're doing here is we're using a ground-based encoder to send a signal into the cloud or into a region. Generally, the way AWS works is we have a number of regions throughout the world, and within each region we have a number of availability zones. So this allows customers to build redundant workflows, build scalable workflows, and allow them to get everything they need within a cloud without needing to have excess say hardware on premise, or you can turn these services on and off actually when you need them. So you can run a 24/7 channel on these, but you can also run them for event-based. So in this scenario here I'm showing is that we've got an encoder encoding whatever the content may be, and we're sending that into Media Connect. That can be using SRT, that could be using RIST, and that could also be using Zixi. The preference is entirely up to the customer and what their workflow is. In this case here, we're using Media Connect as the receiving point because of the protocols it supports, and this also allows you to send the content onto, in this case, Media Live, a media package for encoding and packaging. You can use other instance type. Think of the media services like Lego Technic Bricks. You can pick and choose which ones you use, and you can combine them all together as well if you need to. But in this case, you would create, for argument's sake, your ABR ladder, and then you would feed that through to media package, and then use your CDN to deliver that to the contents. Normally what would happen in other scenarios is the encoder, the packager might all be on premise. They're hardware that you've got to scale, that are sat there running 24/7. You need to wait, you've got lead times to get them, and then obviously you have the uplink, whether you have a cache locally or you're getting your CDN to pull directly from your packager. Running this in the cloud makes life a little bit easier for you, and I think one of the things I enjoy the most is that you can spin this up in 10-15 minutes, and you can test something. If you can fail fast, and then you can start again. You don't need to be waiting for hardware. So that's one of the simple ways of doing this, but you can add layers and layers of complexity onto this. You can add redundancy, you can add completely different steps. So the next slide here is an example of
Love you, Milo.
a playout architecture running in AWS, and just running through this here. So this is an SDI signal running into an elemental encoder. It's been encoded into 2110/22 JPEG XS and sent via Direct Connect into Media Connect. And you can have a number of these feeds running in, and you have a playout facility, whether that's adding graphics, whether that's adding subtitles, anything you would do with a normal playout. You can do this in AWS, and then you can feed it onto your flow. What this diagram's actually showing you here is a redundant architecture. So you're using two identical signals coming in, you're feeding them into Media Connect in two availability zones within your region, and then you've got separate outputs going down here. So just to be clarity sake, in a lot of services from AWS and other providers as well, things like Media Live and Media Package, they defaultly run as multi-availability zone services. So they would be presented to you as on a region basis. So you'd see a region, but under the hood there'd be two distinct pipelines running in different availability zones. And in this example here, we're getting the video signal into AWS, we're creating the playout that we need, we're using the playout EC2 instance to create the various signals that we need, or the channels that we need. We're feeding that back into Media Connect, which acts like almost like a cloud DA. You can take the same signal and send it to multiple locations. And then we're using Media Live here to create an ABR ladder, Media Package to package it, Media Tailor for server-side ad insertion, so changing of the streams, and then distribute it out via your CDN of choice to your end users. In this case, we're also using a CDI connection to a different instance of Media Live, and we're creating a variable bitrate HEVC stream and then pushing that out for uplink to your satellite networks. So this is the capability of running your entire playout chain in the cloud. So some of the good points of this is you can template this, so you can have this you can control this via CloudFormation, via things like Ansible. You can terminate this when you're not using it. You can spin it up when you need it. You can also leave this running 24/7. Which we'll cover later on, there are some cost models that you need to think about when you look into running these on event or 24/7 basis. We will be talking about that in later sessions of this. But in this diagram, this kind of shows you that you could spin this up, use this for an event, for a sporting event that runs for 3 or 4 days. You can tear it down at the end of it, and you haven't got that hardware there. What we also see, and this is more to the talk of the 2110 side and the wider picture when it comes to sort of AWS and cloud broadcast, is live production in the cloud. It's been spoken about on by a lot of people. There's a lot of options to do this. And I like this diagram because this diagram shows how you can use AWS and use these signals here. So you've got your 2110 cameras, you've got your Dante, you've got your return feeds in there, and you're using a contribution encoder to send that via dedicated fiber or direct connect into AWS. And then in this diagram, we're using Media Connect here to take this JPEG XS stream and break it down or decode it into CDI, then moving that across your multiple EC2 instances within the availability zone. So switches, graphics, routing, edit bays, and then you can send that back to it. And in this case here, again, we've got the multi-availability zone service. So the options are kind of endless here. What you can do, you can add, you can remove, you can scale up. And as I said, with these can be templated. You can have a web page here where you say, I want to spin up a 16 channel bay, I want to spin up a 4K edit bay for this with all this infrastructure, and that will spin up and within AWS using templates like CloudFormation, and it will return you ingest points. It will return you so when you use CloudFormation, it will return outputs that you specify in there, so you can choose what you want to output. So input addresses, what PIDs you want to use, various other points you can all control within those templates, and then you can use this for an event, for a race weekend, for a trial weekend, and then just terminate it as and when you need to. So with a lot of the technologies we talked about, particularly around, I'll just jump back to the generic slide here. When we talked about these common use and technologies, really depends which protocol you use. Really depends on what you want to achieve. Getting the video into the cloud is not difficult anymore. You can add layers of complexity, you can keep it simple, you can use, if you wanted a simple pop-up channel, you can go straight away with things like Rtmp. You could got the compatibility there. If you've got on-premise equipment, like we're seeing people flipping their multicast traffic, so their RTP with Feck traffic going around their video network. They're using things like Zixi senders, they're using things like Edge from TechX to pick up those multicast signals and send them out via SRT, RIST, and other protocols into the cloud. So no re-encoding of signals. And one other common use case we're starting to see with our customers, particularly around getting video into the cloud and utilizing it, is using a service like Media Connect, which allows you to share video with either customers or partners. Just as an example here, where this slide is just using video distribution to move from one data center to another data center. What the other capabilities we have is we can do something called entitlements, which can be used by rights holders or host broadcasters to push their streams into AWS, and then they can entitle other broadcasters to use them. So you could go to a national broadcaster showing an international event, you can get the signal from there, you can talk to them, they can entitle you to the stream, and then you can pick that up. So you don't need to be using satellite connections, you don't need to be using downlinks or the private fibers. If the host broadcaster is already going into AWS Media Connect with that, you can get an entitlement to that feed and pull it either into your infrastructure running within AWS or within the cloud, or you can use Media Connect to pull it back down to your on-premise using things like Zixi, SRT, or RIST. And that's kind of, I'm seeing a lot of that from people, that they're picking up feeds from third parties, and they're, instead of pulling it even down to on-premise, they're just connecting the feed from the host broadcaster or the distributor, and then bringing it into their VPC within AWS and creating an ABR workflow or a distribution workflow, bringing it down to on-premise, doing what they need to do with it. So yeah, getting video into the cloud now is not difficult, and there are a multitude of different options and ways to do it. So kind of your imagination's kind of the limit here, because as long as you've got options, whether you want to move uncompressed video, compressed video, if you want to share it across different regions of the world, if you want to process certain portions in the cloud, you want to send it back down to a site to be uplinked, you've got plenty of options. So I'm coming to the end of my presentation now, so hopefully it's been knowledgeable, hopefully it's been helpful and you've learned something from this. But if you've got any questions, please feel free to ask them now.
David, thank you for that. I think it's quite remarkable that a company that started 25 years ago as an online bookseller is now a major player in the storage and distribution of content, although there is a logic and a theme there that actually the content in those days was books, and now it's lots of ones and noughts and digits. So life is a big circle, I think. If you do have any questions, there's one or two coming in. Did you get Viviana's point about standard inputs and outputs there, David? I wasn't quite clear on that question.
So the question from Viviana is around, I didn't fully understand it, but I can get the gist of the conversation, gist of the question from her. So the, just to kind of, I've lost the chat a second, give me a second. So Viviana asked, is there a reason why an input to be a standard requirement for a standard output, even though having a single input should make the outputs of the standard be aligned? You can have multitude of different input types. You can, when you talk about things like input failover or redundant inputs, there are mechanisms in there to align those points in, and there are, I think she was talking along the lines of, but Viviana, if you've got a specific question, please feel free to reach out to me via LinkedIn or anywhere, and I'll be happy to answer that. I think we do have a couple of questions.
Yeah, we've got Ben's come in asking you when you envisage TR07 support in EMX.
So we've added in a number of different, I can share a link with this with Ben on there. We've added a number of different steps to do around sort of monitoring the streams, see errors, continuity counts, continuity count errors. We've added a lot of different ones there. What I'll do, Ben, if around the specific one for the TR07, I'll look into that. But I suspect we will at some point, but I will dig out that specific one for you. And I think the next question we had was from Louise. Is this just for AWS? Other cloud providers have different protocols, different methods of doing things. There are software as a solution services that run on multi-cloud. So that is, you can have a compute from any of the cloud providers, and you can run things like an encoding package. You can run a packager on there. You can run a multitude of different softwares from third-party providers or vendors, and yeah, they can run on that. We also have companies offer platform as a service, so they manage all the infrastructure for you, they manage all the services for you, and what you tend to do is you would just provide your live streams to this, another term for them is OVP, so online video platform. So you would just provide the streams for it, but there are multitudes of ways of doing it. So there's platform as a service, software as a service, online video platform, or OVP. These can run on multitude of different cloud providers as well as on-premise solutions. And what happens after playout? So generally after playout, Louise, the content, once it's been prepared after the playout, you would then send it to where you need to go, whether you're going to go to direct to home, whether you're going to do an uplink to a satellite, whether you're going to provide it that prepared content or the output of the playout workflow, what you're going to do with it. So are you going to deliver it as an OTT? Are you going to provide it as a multicast signal over a cable network, for example? The playout, the main reason with the playout is preparing the content or preparing the live channels for playout on your various different platforms.
There's one coming from Mark, which I'd like to tie up with another question that's come in here.
Yeah.
You mentioned that you work with tier one broadcasters and startups, and the question there was, how do their needs differ? And Mark's also put in a question saying, for ingest into AWS, is there any lower cost pricing models for smaller based organizations or startups?
You generally don't pay with AWS, you don't pay for ingest. So normally getting data into AWS in a general purpose, you wouldn't pay to get the data in. You generally pay what we call data transfer out. With some of the media services, there are fees around moving the data. For ingest, low cost price models for smaller based organization startups. So AWS has the concept of free tiering some of the services. not all of them, not the media services, but a lot of the general services have free tier, free low cost pricing models. So generally with the pricing models in there, you could do things like if you were using a cloud encoder, for example, you can use input types that so things like Rtmps, for example, is pretty effective at getting video into the cloud. I know it's an older technology now, but it's still very, very widely used, and it's very reliable. You can also use things like SRT to come in, and generally a lot of the time with these particularly live services, what you would see is people you would pay for things like an ingest for the service to process the video. So generally HEVC, H.264, so two of the main codecs. If you went for H.264 at a reasonable bit rate for your video stream in there, you can minimize the costs. Generally, you need to look at your workflows. There's no point if you're doing a 10 meg output on an ABR workflow, there is probably no point you actually send in a 50 meg stream. You'd probably look at optimizing your ingest stream into the cloud to make sure that you're mitigating any wastage, basically, because your certain services will charge you an ingest rate. But yeah,
David, you did mention in the talk this payoff, which one often hears between latency and quality.
yes.
Of course, customer probably wants both, and you put there that you saw a sort of midpoint of 6 seconds, which seems to be, it's not fast, not slow, but it's sort of bearable. I think you put sport in the 6 second category. I mean, to what extent is latency still an issue? I mean, how do you overcome it? Does this mean there's still a future for dedicated big networks, which some of the 5G evangelists are saying when 5G comes, all these problems will be solved? I'm not sure that's true, is it?
So not necessarily, because in my experience in general video workflows, without necessarily using the cloud in general, if you're moving data around a network, there's going to be a retry method, there's going to be buffers, there's going to be, when you encode video, by its nature, encoding algorithms use a look ahead to look at the video to analyze what the best encoding you can, or how you can encode those videos, the video stream or the group, the GOP, or how you can create the output of the encoder at the best quality. So generally, if you give, in my general experience, the more time you give the encoder to look at so we call it the look ahead window, more time you give the encoder as a look ahead window, the better quality you get out of it, and that's a trade-off of the latency. So the less time you give the encoder in, you can generally, most encoders, they talk about there will be buffers and there will be latency in there, so you can get it down lower. But you can get into talking about things like WebRTC, which are incredibly low latency, and you can get into points there. But for sort of tier one, as you mentioned, the sporting events there, I think there's always going to be protocols that you're going to retry. There's always going to be recovery methods for moving the data around there. And there's always going to be a trade-off. There's always going to be a point where you want the best quality.
Yeah. Just tease for some of the upcoming sessions, which you did give us one. Once again, the language of IT coming across into the broadcast industry, spinning up, which all my telco friends are using all the time.
Yeah.
Where are we now with this? Are there some people who still want hardware on premises and what have you, and haven't got into the pay as you need, pay as you go? And do finance directors get it? I mean, I know we're going to deal with it later in the week, but
yeah,
from where you sit, are people getting it, or are there still some people saying, no, this is not really where we want to be?
Yes and no. There's a big push kind of around, people have existing data centers with infrastructure in there, and at the moment there's still always going to be a need for, in certain workflows, things like SDI, there's still going to be 2110 video, which as at the moment we're given the speeds of it, isn't always the easiest method of to transport around the internet or networks, as we know. And then there is still a need for on-premise solutions. There's still But it tends to be, I see a lot of hybrid workflows. I see a lot of people taking things out of things like packages and things like caches out of their data centers, or they're using contribution encoders to take their on-premise play out and bring it into the cloud. So I don't think we're ever going to see a full, well, it'll be a while before we still see sort of the data centers going well. There's still things like SDI and 2110 going on in like TV stations.
You did one slide there, which I think was probably a bit of bait for me, where there was a live production slide, and I saw these cameras going into the cloud. And the one you particularly waved in front of me was I saw a director sitting at home. And you know, by definition, they're very often using commodity networks. I do recall BT talking about when they started at the pandemic, like the commentator sitting in Norfolk, the director in South London. The general point here, that the pandemic, I think, has accelerated some of these techniques, which are places we were going anywhere. What does that look like from where you sit? Has the pandemic accelerated progress?
It has and it hasn't. I've seen a lot of push around. Well, one of the things here is there was a lot of a push to run stuff in software as a service or platform as a service, because people weren't getting into TV, they couldn't have Rackman go in, install some encoders, patch some SDI, because they weren't allowed to do that. So we were seeing drives where people get using the cloud for that. We're also seeing the video conferencing boom, the fact that you were talking to people. The pandemic did make a lot of change and a lot of move to the online side of things, but I suspect we'll see a little bit more of a change back. We'll see some of the on-premise stuff, particularly around the tier one side of things, and we'll also see more of a hybrid flow, in my opinion.
Excellent. Well, I think we're running out both of time and of questions.
We've got a couple more.
Billy's got one, yes. Do you want to pick that one up?
Yes. For premium live sports channels where high quality alerts are key replacement, where are we at the cloud? Does CDI really unlock? In my experience, I've seen some.
Do you want to just repeat the question?
Yes, of course. So for premium live sport channels where high quality and low latency are key requirements, are we there yet with the cloud? Does JPEG XS and CDI really unlock the capability to do this in practice?
Doesn't sound to me as though Billy's convinced by what you've been saying.
So there are challenges, and one of the big challenges that a lot of people see, particularly around when you get into live video, is particularly first mile, and getting the information into the cloud, or getting the information can be tricky, because you can't trust public internet, in my opinion, to do video. So you would need to use something like, as you said, you talked about these private dark fiber networks. You've got the AWS Direct Connect solution, which is a fiber we talked about going into your local AWS point of presence and gets you onto the backbone. I've seen people, Billy, I've got customers, and I've seen people using 2110-22 output of an SDI encoder, doing that into it, and then using that in using CDI within an EC2 instance. It's getting there. I wouldn't say the full compatibility from all the providers is for all of the solutions is there, but it's definitely getting there. Things are picking up on the cloud side, and I think one thing I see a lot of is someone says, I want to use my particular type of switch, or I want to use my mixer, I want to do that. And if that is, a lot of the time, they need to add in custom SDKs to get it to work. They need to add in, apologies, I've been hijacked, add in custom SDKs and stuff to get things working. So it's still work in progress, but it's getting there, in my opinion. It's come up a lot recently.
So there's still some more work for you to do, which is great.
There's always work to do. And I think there's one more question from Mark there. You spoke about Rtmp, is this still a common method for ingest of compressed medium, or are you seeing more and more SRT and RIS being used over Rtmp? So very, very good question, Mark. Rtmp is very, very widely supported. It's a load of encoders do it as an output, a load of service acceptors and input. Facebook Live, YouTube Live, Twitch. We're seeing switches from certain people that are now allowing HLS in for that. I like SRT and RIST, and I think they are much better than Rtmp because they're obviously newer, still being developed. There's a lot going on there, but I am seeing a lot more SRT and RIST from broadcasters, but a lot of the prosumer side of things and certain points is still Rtmp. So it's still widely supported. But yeah, I am seeing more SRT and RIST going on. Yes.
Great. David, thank you so much. I mean, I think it's been a wonderful session because not only have we been treated to all this technology, we've had a moment of zoo time as well. Some of us are old enough to remember zoo time, to have the black cat walking across. Black cat walking across a webinar. I'm not sure what that means, but I hope it's not bad luck.
Hopefully it's good luck, yeah. Hopefully it's good luck.